Hello everyone, my name is Mingde Zhao and I'm a student at the University of Wollongong. Today I will be presenting my research for the subject ENGG 955 and my research title is Evaluation of Fiber Reinforced Geopolymer Concrete Incorporating Treated Recycled Aggregate under Freeze and Thaw Conditions. So I will present my report into four parts. The first part is introduction and motivation, and the second is literature review, and the third is research design, and the fourth is result. Let's come to the first part, the introduction and motivation. So GPC is the sustainable alternative for the concrete because concrete is the most used material globally. But GPC is a cement-free material, reducing CO2 emissions by up to 57.62% compared to the OPC. However, GPC also has some problems. It's often brittle, and incorporating recycled aggregate increases sustainability, but can reduce freeze and thaw resistance. With fiber content can compensate the flaws. So my research focused on the combined performance of fiber reinforcement and treated recycled aggregate in GPC under freeze and thaw conditions. Let's come to the literature review part. So there are studies already investigated the fiber reinforced GPC and found that with the fiber reinforcement, the can improve the mechanical strength of the GPC. Also, there are studies investigated the treated recycled aggregate in GPC and found that with the 100% TRI replacement, the compressive strength only dropped around 5%. And come to the freeze and thaw resistance for fiber reinforced GPC. A study investigated fiber reinforced GPC found that the polyester fiber significantly improves the freeze and thaw resistance, while the steel fiber has a negative impact. And the combined use of fiber with the recycled aggregate in GPC. A study also investigated the steel fiber reinforced GPC with up to 40% recycled aggregate, found that the RA will reduce the strength and the steel fiber will improve the mechanical properties. And the optimum content is 30% RA and 0.6% of steel fiber. However, this study also has limitations. The RA replacement is not 100% and only investigate the steel fiber. So come to my research design. Before the study start, so we have to treat the recycled aggregate first to remove the attached motor, and the recycled aggregate will put in a rotating drum and for 200 rotations. This can effectively remove the attached motor. You can see the photos for the untreated RA and the treated RA. There are some differences. And totally 21 GPC mixes were prepared with the 0 to 100% treated recycled aggregate replacement at 25% intervals. Each mix incorporating 0.25% or 0.5% glass or polyester fibers. So you can see from the table at the right hand, there's this detailed mix proportions. And the test, comprehensive laboratory tests were conducted to evaluate the mechanical strength and freeze and thaw resistance. So the experiment can include the SLAM test, compressive strength, stability tensile strength, flexural strength, and freeze and thaw resistance. The freeze and thaw test involves 120 cycles between -20 to 20 And so elaborate assessment of how fiber type and the TRA replacement levels affect GPC durability and force resistance. So the results found that with 100% TRA replacement caused only a 5% drop in compressive strength, while 0.5% polyester fiber significantly improved the mechanical and freight and saw performance. Although higher TRE content significantly reduced the frost resistance, fiber reinforcement effectively compensated, making TRE GPC a sustainable alternative to nature aggregate. So that's all for my report. Thank you. Thanks for listening.